All right, so the last section we're going to look at this week is 8.2, and that's on the law of cosines. So for law of sines, let's start with that. Did anyone remember the three types of problems that we were able to do with law of sines?
Sine, side, angle.
Okay, so we had side, side, angle. Yep.
Angle, side, angle.
We had angle, side, angle. Yep.
Side, angle, angle.
What was the last one?
Side, angle, angle.
Side, angle, angle. Yep. Or angle, angle, side. Same thing. Yep. So those are the three that you can do with law of sines. And remember, these letters tell you what information you're being given and the placement. Out of these three cases, which one is the one that could have the 0, 1, or 2 solutions?
Side, side, angle.
Right. So that's the one where we got to be careful and check everything. All right. So now we're going to look at law of cosines. Right? And I'm going to show you what two types of problems we can do with that. Okay, so that's what we used for law of sines. Law of cosines is going to enable us to solve these two types: side, angle, side, and side, side, side. That's every type of triangle problem you could have. There are no other types. Okay, so side, angle, side. Well, it looks just like the letters tell you. They give you a side, an angle that's between the two sides, and then the other side. For side, 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 well, they give you all three sides. How come you would never have like angle, angle, angle?
Any size.
Right, you wouldn't have any reference for the size. Like if I said, I want you to tell me all the lengths in the following triangle. The angles are 60, 60, 60. Well, you know it's equilateral, but you don't know, is it a small equilateral or a big equilateral? The sides could be anything. So no matter what type you're doing, you always have at least one side in every type. All right, so now, well, let's see what happens if we tried law of sines on this problem. Okay. We don't have to write it yet because I haven't given you the law of cosines yet, but I just want you to look at it and watch me try to do law of sines. Then I'm going to give you law of cosines. Okay. Let's pick something we would try to solve for first. All right, let's try to solve for C. Again, if you were trying to solve for C with law of sines, you definitely have to use row C, okay, because that's the row that has the letter in it you need. So you would try this. Sine 42 over C equals, and then what row would we use on the other side?
You can't.
You can't, because there's no angle in any other row.
Right, it doesn't matter if you pick the top row or the bottom row. Pick the top row. You have sine of alpha over A, and what's the problem with that?
Now we have a letter and we have an angle that is not defined.
Yeah, so we're missing two things. That's a problem. So if you say, well, what if I picked the second row? Well, you'd still be missing two things. No matter which two rows you pick, the first two, the last two, or the first and the last, you're always going to be missing two things. That's why law of sines isn't going to work. Okay? So that happens with, this is a side, angle, side problem. The same thing would happen with side, side, side. You'd have a piece of information in each row, but you would not have a full row. Okay? So let's look at what the law of cosines is. Okay, so of cosines. Okay, depending on what you want to solve for, you can write it different ways, but the concept is the same no matter how you write it. Right? It starts out like this. Okay, what does that kind of look like?
Pythagorean
Yeah,
theorem.
what does it look exactly like? Yeah, it looks like Pythagorean theorem. So if this was a 90-degree problem, then that's a formula you could just use the way it is. But when we're dealing with a triangle that doesn't have a 90, we're going to subtract something from that. And by putting this adjustment on the end, it allows us to use the Pythagorean theorem with kind of an adjustment because the angle is not 90. Okay? So it starts out like that. And then it has a 2. And it's the product of the two letters you wrote immediately before it, A and B. Now, it's the law of cosines. So what do you think's missing there that definitely has to be in the formula to be called the law of cosines?
Cosine.
You better have the cosine in there. So that's the last thing that comes up. And it's the cosine of the angle across from the letter you started with. What angle is across from C?
Yeah.
Gamma. Yep. So that's the law of cosines. In general, it's one side squared equals the sum of the other two sides squared minus twice the other two times the cosine of the angle across from the letter you started with.
And you would just switch the order to solve for A or B, correct?
Yeah. So if we had, let's say instead of gamma, we were doing something with alpha. So that would start out like that. What do you think would come next?
B squared, C squared?
B squared plus C squared. So one side squared equals the sum of the other two
Minus 2BC
Minus-
cosine alpha.
twice the other two times the cosine of the angle across from what you started with. Okay. I mean, you can write this infinitely many ways if you use all different letters. You could use letters A, B, and C. You could use X, Y, and Z. You just have to follow that same pattern. Okay. So this isn't really three different formulas. It's the same formula, just written different ways. How about the one that starts with B squared?
A squared, C squared?
A squared plus C squared
Minus, go ahead, sorry.
Sorry. Minus 2AC.
minus 2 AC,
Cosine beta.
cosine of the angle across from what you started with. Yep. So those are all called, that's the law of cosines. When you're using the law of cosines, there's really two different ways we use the formula. Sometimes we use the formula to find an angle. Sometimes we use the formula to find a side. It depends on what you're given. If you are given a side, side, side problem, you're never going to be solving for a side because they gave you all the sides. Okay? You're only going to be solving for angles. If they give you a side angle side problem, you're going to do a little of both. Right? You're missing a side here, so you have to find that. And you're also missing some angles, so you have to find those. Okay? So side angle side covers everything that can happen with law of cosines. Side, side, side doesn't. It only covers finding an angle. So we're gonna start out with the one that covers everything. Side angle side. Everyone have those formulas? All right. And it's good to understand the pattern of it because I might give you a diagram at some point and it might not have any labels on it. So then you have to kind of understand what the pattern is, right? Rather than having specific labels on the problem. Okay, but let's start out with one that has labels. All right. By looking at that, we know it's not law of sines because we don't have a full row. So does that, it means it's law of cosines. Is it side angle side or side side side?
Side angle side.
Yeah, it's definitely side angle side because you don't have a third side. So it's not side side side. When you are doing side angle side, you have to find the missing side first. After that, you can do whatever you want. Okay, but to start this problem out, you have to find the missing side. So if we look at our three kind of different versions of the law of cosines, I have to pick one that I can plug into and only be missing one thing. If you pick a version of that and you plug into it and you're missing two things, you picked the wrong one. You're going to have the same problem you just had over here. So out of these three different versions, would I use version 1, 2, or 3?
Version
Version what?
1.
Yeah, you have to use version 1 because you're missing C. That means you're already missing something in every formula. Okay, and C appears more than once, but it appears in every formula. If you're missing C, you can't be missing anything else. Okay, so let's try version 1 and see what happens. So we've got C squared equals A squared plus B squared. In the future, I'll probably just do that out in that step, so I don't have to write it twice. But first time, I'll just write it all out. So A squared plus B squared minus 2 times A times B. That's 2 times 4 times 7. Times the cosine of the angle, in this case, gamma, cosine 42. Okay, so that's how we set the formula up. Any question on the set? Okay, now what's the angle that I'm plugging in for cosine in this one?
42.
42. So when I take the cosine of 42, I'm going to get a not nice answer, so we'll deal with that. But even if this works for any angle, whether it's a 42, an 87, it even works for a 90. Okay? If that angle was a 90 and you fill it in, the cosine of 90 comes out to 0. Then it basically turns the formula just into Pythagorean theorem. Yep. So if this angle is a 90, this whole part cancels out. And that's why we can use the Pythagorean theorem the way you learned it for 90s. You don't need this part because it's always a 0. Now we're looking at problems where that's not a 90, so that part is not 0. Okay, so let's do all this out. 4 squared gives me how much?
16.
So 16. And 7 squared? 49. And 2 times 4?
8.
56.
8 times 7 is 56. Cosine 42. So next step, we're going to add 16 and 49, and that gives me how much?
65.
That gives me 65, yep. Minus 56, cosine 42. Now, just make sure we follow order of operations. What's the next thing we should do there?
Multiply 56 and cosine 42.
Yeah, the next thing you would do is you would multiply these two together and then subtract it from 65. But I'm gonna do all that at once. Okay, the less rounding I do in the problem, the better. So let's not even do that out yet. I'm not even going to worry about it. Let's just get rid of this exponent of 2. And I'll type it all in one step. So if that's c squared, how am I going to get c?
Square root it.
Take the square root. Yep. And by typing it in that way on the calculator, I have not done any rounding in this problem up to that step. So the only rounding I'm going to do is right now. So it's the square root of 65 minus 56 cosine 42. So I'm actually never even going to figure out what 56 times cosine 42 is. I don't care what 56 times cosine 42 is. I care what you get when you subtract that from 65 and then take the square root. That's what I care about. All right. So that gives us a value of 4.835. 4.86. Any questions why I did not round that before the last step? Any rounding you do is going to throw your answer off. So try, if you do need to round, just round one time in the problem at the very end. Right, if we need to round more than once, we can, but we definitely don't need to in that problem. All right. So 4.836. And that's pretty much how a law of cosines problem goes every time you need to find a side. That's it. Okay. The nice thing about finding a side is the variable, it's not completely by itself, because you still had to do something to get rid of the exponent of 2, but it was pretty much by itself the whole time, okay, with the exception of the exponent. That always happens when you're finding a side. All right. Now we need to find an angle. Let's draw the triangle we have. Okay, we were given A, we were given B, and we were given, we were not given C, so I'm going to leave that as C. And that was 42. What kind of triangle did we say that this was originally? Yeah, it's a side angle side, which is law of cosines. Now we have an extra piece of information. We know this, 4.836. That makes this triangle other types now, the side, side, angle, side. What's another type that this would fall under now?
Side, side, side.
You could think of it as a side, side, side.
Side angle side. Oh, wait, I'm sorry. Side side angle.
Or you could think of it as a side, side, angle. Or think of it as side, side, angle. Either way.
So could you use law of sine to finish it?
So if we think of it as side, side, angle, this one falls under law of sines. But what do we know about side, side, angle?
But they can
Oh, we
have
have two solutions.
So that's the one where we can get into the two solution, no solution. So we don't, it's not that we can't do it that way, but we'd rather avoid doing it that way. So we're going to finish this with law of cosines. Okay.
But for other triangles, we could finish it with law of sine, if it makes sense.
Well, the only case that's ever going to come up
It's
today is
side,
that
side,
one.
angle.
So every time we do a law of cosine problem, I would recommend finishing it with law of cosines.
Wait, why can you not do side angle side? You can get no solution on all solutions.
This bottom one, side, side, angle?
No, the top one? Oh wait, no, hold up, yeah,
That's
that's.
the one.
Yeah, we're talking about why we can't do the bottom one. And you can, but the thing is, you got to deal with more stuff if you try to do it this way. Where if you just use law of cosines, it's going to give you the one answer right away. And you're not going to have to worry about anything else. All right? Okay, so now, because we have all the sides, you can pick either alpha or beta. Which one do we want to try to find? Alpha. Okay, so we're going to find alpha.
I'm already doing beta, so it doesn't matter.
Oh, you did beta, okay.
I'm already doing beta, so.
So we'll see if we get the same thing when we subtract our answer from 180. So we're going to find alpha, which means you're using the second formula. A squared equals b squared plus c squared. Okay. So let's go back up. Let's do some of it as we go. What's a squared?
16.
So 16. A squared equals b squared plus c squared. What's b squared?
49.
49. Now, c squared, well, I never really got that, but I can just type it in. Just type in what you had right here, but don't take the square root. Okay.
Do you not want the rounded version when we're doing this part?
Right, that's why I'm not going to take 4.836 and square it. Okay, that is c squared, but I'd rather go back to the exact answer for c squared, because there's no rounding. So it was 65 minus 56 cosine 42.
Oh.
65 minus 56. Okay, so that's the exact answer for c squared. if you're just 4.836, it's probably not going to be bad because we had 3 decimal places there. But it does throw it off a little bit. That's 386 versus 384. So it's a little bit off. So go back to the exact answer. So 23.384. Okay, so 23.384. All right, so we got a squared, b squared, c squared. And what's going to come after it? Minus
2 times BC.
2 times bc. Okay, so now we need 2 times b times c. Well, what's 2 times b?
14.
14 times c. 4.836. Okay, 67.704. 67.704. And the last part, cosine alpha. Okay. Now, this time, the variable is surrounded by everything. So the variable, eventually, we have to get that by itself. Okay? That's the opposite of what happened up here. The variable was pretty much alone the whole time. Now it's not. So we're going to have to fix all this stuff and put it on the other side. All right, so first we got a few like terms. What can I combine for like terms on the right?
Everything besides the 67.704 and cosine alpha.
So we can't do anything with the 67 right now because that's multiplied by the
so everything
cosine.
besides that.
Yeah, everything besides that, yeah. So 49 plus 23. And add that up. Gives you 72,384.
Where did the 14 come from?
2 times.
The 14?
It's 2 times b.
Oh.
I don't even see it.
Oh, it's on the calculator.
Oh, it's on the calculator. Oh yeah, so 14, that was 7 times 3. That was 2 times b times c. And b was 7. So 2 times 7 is where the 14 came from. Okay, so we added 49 and 23, and we got 72.384 minus 67,704 cosine alpha. Now, the next step in that equation is exactly the same as the next step in this equation. I just simplified it and took out the decimals and made it look simpler. We have 16 equals 72 minus 67 times something we don't know. If you were trying to get x by itself here, what would be your next step?
5 by 67. Subtract 72.
Right, you would subtract the 72. Okay. And that's exactly what you need to do up here. Subtract the 72. You can't do 72 minus 67. If you're wondering why, they're not like terms. The 67 is multiplied by something that you don't know. So you cannot do 72 minus 67. 4, that's gone. And now I need 16 minus 72.384. Okay, that gives me negative 56.384. Perfectly fine if you get a negative number at this step. Negative number for the final answer? No, that's bad. Okay. But negative number right now, no problem. Equals. All right. So now we're getting closer to having alpha by itself. What would be my next step?
Divide by negative 67.
Yep, so divide each side by negative 67.704. And negative 67 is going to cancel on the right, and negative divided by negative is going to cancel those on the left. Okay. This I'm not even going to do out. Just leave it as 56 over 67 with their decimals. Because if I do it out, I'm just taking something that's already rounded and just rounding it again. So just leave it the way it is. Right, and now we're down to our last step to get alpha by itself.
Inverse cosine.
Take the inverse cosine. Yep. And take the inverse cosine. And what do we know about inverse cosine in terms of numbers you are allowed to take the inverse cosine of?
They can only be between -1 and 1.
It has to be between -1 and 1, which means if you, and this will never, yeah, it has to be between -1 and 1. And if you have a bigger number in the bottom of a fraction than the top, that will make it less than 1. If you ever end up with a bigger number in the top, like let's say you ended up with 10 in the top and 3 in the bottom, well, you're not taking the inverse cosine of that. Something went wrong, okay? Because this kind of problem is never no solution, all right? So the bigger number should always be in the bottom. Right, and inverse cosine of 56.384, 67,704 gives me an angle of 33,612. Okay, so that's alpha. And the easiest way to find beta, I would say just add the two angles you have and subtract from 180. Because you've already done so much rounding and you had to depend on other things to find things. So if you got C wrong, well, you already have alpha wrong. So but we're going to use alpha to find beta. Yep.
Are you in degrees on your calculator?
I hope so.
Okay.
I'm pretty sure.
Yeah, I think you are.
Yes.
I went beta, started with beta, I got 33.608. Was that close enough for like, for
Well,
alpha?
let's see. So it's
No,
180.
Yeah, 33.608 for alpha.
You had
Close
608.
Yeah.
It's pretty close. It's a little bit off, just probably because of rounding.
Yeah.
0.612, and then subtract the 42. So that makes the last angle 104.388. And make sure you put a degree symbol on the angles. You don't need a degree symbol on C because C is not an angle. But that's a pretty typical side angle side problem. That work was finding a side. That work was finding an angle. When you're finding a side, you will never use inverse trig. You'll finish the problem by taking a square root. When you're finding an angle, that's when you'll finish with inverse trig. All right. Any questions on that? All right, so that's side angle side. Let's try this one. I think it's pretty easy to recognize what type this is without a picture. Just look at what they gave you. What did they give you here?
Side, side, side.
Side, side, side. Yeah. Okay. Side, side, side. Is that a law of sines or cosines problem?
Cosines.
Cosines. Right. You do not have a full row, so there's no way to do law of sines on that. But you do have every side. So because you have every side, you can do anything you want in any order you want. So we just have to pick an angle we want to find first. We've already done alpha with law of cosines. We did that right here. So let's do a different one.
Gamma.
Gamma. Okay. So let's find gamma. And remember the formula for gamma starts out with what letter? C squared, A squared, B squared, minus 2AB cosine gamma. Now, what's nice about side, 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 not always, but a lot of the time, is the sides are all nice numbers. Okay? 9, 7, 5. Okay. All right, so let's try that. What is c squared?
25.
25. A squared?
81.
81. And b squared?
49.
49. And 2 times a times b. Well, 2 times a is 18. 18 times 7,
126.
126. Okay. All right, what would be the next thing we do on the right-hand side?
Combine like terms.
Combine like terms. So we have 81 and 49. That gives you 130. Cosine alpha. Okay, how about your next step?
Subtract 130 from both sides.
Subtract 130. And what's 25 minus 130?
Negative 105.
Negative 105. Again, negative at this point is fine. That's not a problem. Okay, second to last step.
Divide by 126.
Divide each side by negative 126. Negatives are gone. 126 is gone. Negatives are gone. Don't do 105 over 126 out. Just leave that as an exact fraction. So in this problem, we've not done any rounding. There's been no rounding. That's an exact answer up to this point. Now, my last step, we're going to round. What do we do last?
Take the inverse cosine of both sides.
Take the inverse cosine. Inverse cosine. That cancels out. And we get inverse cosine of 105 divided by 126. 33.557. And because there was no rounding, there's no reason why we shouldn't all have exactly the same answer for that one. 33.557. Okay. So now that you have an angle, you could treat this as a different kind of problem, but for the reasons I've already mentioned before, I would finish it with law of cosines. You would have to do law of cosines one more time, either for alpha or for beta. It wouldn't matter which one. Okay. Is there any question how you run through that one more time to find one of the other angles? It'd be all the same numbers again, they just all move to different spots. Yes?
Could you use law of cosines for both answers just to check your answers anyway? Like
You could, yeah. Yeah, so if you had extra time and you wanted to do law of cosines here, here, and here separately, you could. Okay. The nice thing about doing it that way is if you make a mistake on one part, it would have no effect on anything else. So this is a problem where you can find all three of these totally separate, and a mistake wouldn't affect anything other than the one thing you were trying to find. If you do it the way I suggested, right, you find this with law of cosines, and then you add these two together and subtract from 180. If you made a mistake on one of those two, then you automatically would have a mistake on the last one. Right? But it does take longer to do it the way you said as well. But it's safer. Yeah.
So depending on which one you're trying to find first, you can just kind of change the law of cosines, whatever you need to
Yeah.
do whatever one you want.
Yep.
So we're just moving them. Okay.
Yeah. We're just changing the letter we start with, and then everything kind of follows a pattern from there. Yep. So any other question on that type? Okay, let me. All right, so let's take a look now at a word problem. Okay. So just to kind of set up what's going to happen in this problem, we're trying to find the distance between 2 points. Now, it could be on opposite sides of a canyon. could be at opposite sides of the house, but for whatever reason, it's not easy to just directly measure the distance. A canyon would obviously make it a lot harder than a house, but yeah, so we got 2 points. We're trying to find the distance between. And they're on opposite sides of a house. So to find that distance, what I'm going to do is I'm going to stand in front of the house, and I'm going to look at point A, which is on one side, and then I'm going to look at point B, which is on the other side, and I'm going to measure the angle, like if I'm facing this way, and then I turn, I'm going to measure the angle that I have to turn when I'm looking at each point on the sides of the house. And that angle is easy to measure if I have like a transit. It's something like a surveyor would use. I can measure property lines, boundaries, and distances with that tool pretty easy. All right. The other thing that I can easily measure is if I walk over to point A, which is on one side of the house, and set up a tripod, and then I go back to where I was standing, I can shoot a laser at that object that I just set up, and it'll tell me how far away it is from me. So that's also easy to measure. Right. So they give us a lot of information, and I think what's really going to help is a diagram. Okay, so we've got to put all of this in a diagram. Okay, so I've got the house, and let me find. So the reason that we can't measure the distance directly between the two houses is because there's a wild cheetah.
Yes.
Okay. And if we try to measure the distance between the two houses, the wild cheetah is going to get very upset. And we don't want to get upset. And the other thing that's also guarding the two houses is a chicken.
Oh, okay.
But they're friends, so they're not going to hurt each other. But they're very dangerous to humans, especially the chicken.
Very large chicken.
Yeah, the chicken's bigger than the cheetah. That's why the cheetah's okay with it.
This chicken's bigger than the house.
Yeah, it's a big chicken. All right, so we can't measure the distance between point A and B. So we're going to label everything they told us in the diagram. Points A and B are on the opposite sides of the house. The surveyor is going to stand at point C. Okay, I don't have a picture of a surveyor, so we could use.
Wait, there was a person there.
I did.
No.
Construction worker.
I did. How about a conquistador?
Yeah.
It's just because I found it quickly. There's no reason why.
Okay.
All right. So that's our surveyor at point C. Could have used a construction worker too.
Oh,
If you want to, we can switch it.
no, it's okay.
Okay.
I like that one better.
All right. So the surveyor is going to measure the angle from point A into point B. That's the amount they have to turn, and that's 54 degrees. Angle ACB. The distances, I put those down. The distance from the surveyor to point A says is 110 feet, and it's 160 feet to point B. Okay, so our goal is to figure out the length of side AB. That's the distance between the 2 points. All right, so let's take our triangle. And I'm just going to move that off to the side so we can just focus on that. What kind of triangle is the one that we have right there? That is a side angle side. Right? So you can find the side you're missing right away. All right, so let's see if we can find that. For now, let's just call it X. I'm not using A and B. I've already used A and B for those other points. So let's use something different. If I want to find X, it's going to start out as X squared. Okay? And now, this is where it's important to kind of understand the pattern, not the specific names that you're using. What's going to come after X squared?
110 squared plus 160 squared.
So one side squared plus the other side squared
Minus 2 times 110 times 160.
minus 2 times the product of the sides you just wrote down. And one more thing.
Cosine of 54.
Cosine of the angle across from the letter you started with, 54. Okay, so we took the information from the word problem, we drew it out, kind of abstracted it to just the triangle so we don't have to worry about birds and cheetahs. And now we plugged it all into our formula, and now we'll see what we get. All right, so we've got 110 squared plus 160 squared. Okay, so 37,700 minus 2. Well, what's 2 times 110?
220.
So that's 220 times 160. Okay, so that's going to give us 35,200. 35,200 cosine 54. Okay, and that's as much as I'm going to do on the right-hand side. Anything else would start to involve decimals. Okay. So what can I do to get x by itself?
Square root.
Yep, take the square root. So that's what you want to type into your calculator, so you don't have to do any rounding until right now. All right, so square root 37,700 minus 35,200 cosine 54. Order of operations, calculator will handle that. If you type it in the way I did, no problem. So the distance between points A and B is 130.422. What's up?
Is it miles or?
I think that was in feet. Yeah, that was in feet. All right, so now we have the distance between points A and B, and we did it safely, and we avoided the cheetah and the chicken. So math brings safety.
Okay.
Any question on that one? All right. So now I will put up this, but let's. Okay. One thing I want to add. So the only way to get no solution with law of cosines is with side, side, side. That's the only time that you could get a no solution. Now, what did we always say about two sides in a triangle?
But
Compared to the third side.
they have to add up to be bigger than the third side.
Right. Side 1 plus side 2 has to be bigger than side 3. I don't care which 3 sides you use. Side 1 plus side 2 has to be bigger than side 3. If that doesn't happen, like let's say I gave you sides of 1, 1, and 10, you can't make a triangle with a 1, a 1, and a 10. It doesn't work. Okay, so 1, 2, 5, 6. Let's go like this. 2, 5, 6. 10 and 19. So I did change that a little bit. So 1, 2, 5, 6, 10, and 19. Okay, and down below, I should have enough time. Pause it, and I'm going to put up the list of test topics.